Hello everyone, welcome to our Part 1 solution for the Chapter 5 assessment. So for number 1, you were given tangent of an angle and you were to find 3 other of the trig functions, and this is similar to what we did in Chapter 4. So the best idea is to make a picture. This tells us that we're in the first quadrant. Draw a triangle. There's theta. We know that tangent is opposite over adjacent. So we can go ahead and label that 5 and 9. So since we need to find sine and secant, which both involve the hypotenuse, or the radius, we need to find this length. So we know that a squared plus b squared equals c squared. R squared is 106. So since the radius can't be negative, we get radical 106. So for A, cotangent of theta is adjacent over opposite. We get 9/5. For B, sine of theta we know is opposite over hypotenuse. So we get 5 over radical 106. Rationalizing the denominator, we get 5 radical 106 over 106. And then for secant, we get hypotenuse over adjacent. And we get radical 106 over 9. Okay, then we were simplifying trig identities. So for the first one, we can easily rewrite 1 minus cosine squared. So recall that sine squared plus cosine squared equals 1. So if I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared. Notice that I have 1 minus cosine squared here. So I can substitute sine squared in for 1 minus cosine squared. And then we know that cosecant squared is the reciprocal of sine squared. And if we put that over 1, notice that the sine squareds cancel out, leaving us with 1. Okay, number 3, we needed to add these fractions and then simplify if we can. Well, in order to add the fractions, we need to find a common denominator. So we'll make the common denominator cosine theta sine theta. So I'm going to multiply both fractions by 1. Cosine times cosine is cosine squared. Sine times sine is sine squared, all over sine cosine. And remembering back to the last problem, we know that sine squared plus cosine squared is equal to 1. So we get 1 over sine cosine. Well, we know that the reciprocal function of sine is cosecant, and the reciprocal function of cosine is secant. So we get cosecant theta secant theta. Number 4, 7 minus 7 sine squared. Well, one of the first things you want to do when you're just trying to simplify is see if you could factor something out of both terms. I see that 7 is a common factor, so I'm going to factor out a 7, leaving me with 1 minus sine squared theta. Well, remember that sine squared plus cosine squared is equal to 1, which means cosine squared is equal to 1 minus sine squared theta. So I can rewrite this as 7 cosine squared theta. Okay, for number 5, we see a cosecant squared minus 1. And if we look at our trig identity sheet, we know that cotangent squared plus 1 equals cosecant squared. Notice that by subtracting 1 from both sides, I get cotangent squared equals cosecant squared minus 1. So looking up here, I could rewrite that as 1 over cotangent squared. And then we know that cotangent squared is the reciprocal of tangent squared. And looking at our Pythagorean identities, we know that tangent squared plus 1 is secant squared. Okay, number 6. On these, we need to verify the identity, which means we want to make the left side equal to the right side. You could also make the right side equal to the left side. But it's common practice to just work on one side until you've made it equal the other side. So looking at the first one, I notice that I've got a cosine and a cosecant. Well, I'm going to change everything to just sine and cosine. I know cosecant is 1 over sine. Put that over 1. I get cosine over sine, which I know is equal to cotangent. Number 7. Like I gave the advice on the first page, sometimes see if you can factor something out. I look at these two terms and I notice that I can factor out a secant squared. When I factor out, I get tangent squared plus 1. Looking at our Pythagorean identities, we know that tangent squared plus 1 is secant squared. So we get secant squared x times secant squared x, which gives us secant to the 4th x. Number 8. We have the quantity sine plus cosine squared. Now, some of you just said that it was sine squared plus cosine squared, which isn't correct. So go ahead and write them as two binomials, and we'll go ahead and use FOIL. So sine times sine is sine squared plus sine cosine plus cosine sine plus cosine squared. So I'm just going to rewrite this as sine squared plus cosine squared. And notice these two really are the same. Multiplication is commutative. So sine times cosine is the same as cosine times sine. So I'm going to rewrite this as 2 sine x cosine x. Well, we know that sine squared plus cosine squared is equal to 1. And then looking at our double angle formulas, which you should have done since you saw the sine of 2x there. We see that sine of 2 theta is equal to 2 sine theta cosine theta. So, we're done. We get 1 plus 2 sine x. Okay, number 9, I think was kind of the first real tricky one. It was kind of open what we wanted to do here. Now, when we say, oh yeah, get everything into sine and cosine, it already is. So anytime I see like a 1 plus sign or a 1 minus sign on one part of the fraction and a cosine on the other, or if I had like a 1 plus cosine and a sine on the other, I'm going to go ahead and multiply this by something so that I can get it in terms, or make it into cosine. So what I'm going to do is multiply both the top and bottom by 1 minus sine x. So on the top, I'm just going to leave that as cosine x times 1 minus sine x. I don't like to distribute until I know I have to. Now, for the bottom, and I'll just show this off to the side, you get 1 times 1, which is 1, minus sine x, plus sine x, minus sine squared x. So notice that the sine x's cancel out, and I get 1 minus sine squared, taking theta again, 1 minus sine squared x. Then using our Pythagorean identities, we know that 1 minus sine squared x is equal to cosine squared x. Then a factor of cosine on the top cancels out with 1 on the bottom, leaving us with 1 minus sine x over cosine x. If we split up the fraction, we get 1 over cosine x minus sine x over cosine x. 1 over cosine is secant, and sine over cosine is tangent. So we get secant x minus tangent x, which was what we were looking for. That concludes problems 1 through 9. Problems 10 through 12 will be done on the next video.